Okay, parts is parts.
Don't mess on the cheat. Where'd it go? You throw it? Yeah, good.
Some of this will be a rehashing of what we've talked about already, but we do have at least one new theorem in there. So we talked about this already. We've got this thing called the scale factor. That scale factor applies to anything that can be measured with a ruler. So I've got a couple examples there: altitudes, angle bisectors, medians, perimeters, side lengths, connecting midpoints, medians. Said that all right. So we knew that all right. So solve for x. Hey, quick question before you do that. What kind of thing is this guy and this guy?
Median. No, that's altitude.
Oh, it's a median.
Median?
Median.
Altitude. Bisector?
Yes.
No.
Perpendicular bisector?
No.
No? What is it?
All of the above.
It's a median, correct. Okay, so solve for x. And notice I already established that the triangles are similar. I told you that, so you don't have to worry about it. If I don't tell you that, you either have to figure it out or you can't do it. Don't assume anything. What's your proportion?
It cheats.
Right on.
Did you get it right?
You didn't show us working. What's up with you, Stanford head?
I don't know.
Yeah. All right, we good? 7.5?
Yes.
How'd you set it up?
Oh.
Sarah?
I don't know. I don't see how.
Did you get 7.5? Okay. No. Hey,
I did x over 12 is equal to 5 over 8.
so you did the median over median equals variable over corresponding side. Anybody set it up differently? Matt?
I did 8 over 12 equals 5 over x.
8 over 12 equals 5 over x. So you did median over median equals, so you took, no, what did you do? Oh, no, wait, Faith, you didn't do that. You did missing side over median equals missing side over, or corresponding side over median. Question?
I just did it a different way. And
How do you
I got
manage that every
7.5.
time?
I got 7.5.
So you would get partial credit. Can't grade your
So-
calculator.
No, I mean I didn't even use my calculator. I did.
Can't
for
grade your
8
head.
For 8 to go to 12, you do divided by 2 times 3. So that's what I did to 5.
Okay?
So does that work?
Yeah.
Alright, cool.
Why? It won't work on the quiz tomorrow. You'll lose
Oh.
points on that because I want to see a proportion.
Okay.
Wow.
Nice circle.
We'll just pretend that happened. Didn't happen. Okay, easy. Angle bisector theorem. So let's look at the picture first before I give you the theorem. I took a triangle and I drew in one of the angle bisectors, and you can tell it's an angle bisector because I got the little tick marks down here showing you that those two angles are congruent. from that angle bisector, or from the vertex that that angle bisector comes out of, it's got two sides. I labeled them B and D. Okay, and I will refer to those as sides. That angle bisector comes across and hits the other side. It does not split that other side equally. Doesn't bisect the opposite side, it splits it proportionally. Okay, so notice in that picture that A is not congruent to C. So, fun question first, before I give you the theorem. What kind of triangle would it have to be in order for A to be equal to C?
Isosceles.
Or?
Equilateral.
Good. If it's an isosceles or an equilateral triangle, then A and C would be equal. But for most of the time, it's not going to happen. And so the angle bisector theorem says the following. Here's all the fancy schmancy stuff. This is what you're going to use to remember it. Okay. So I split this third side into two pieces, which I call chunks. The left chunk over the left side equals the right chunk over the right side. In this particular case, the A, B, C, and D help you see what's going on here, but it's not going to help you in the future because not every triangle is going to be labeled with an A, B, a C, and a D. However, the left chunk over left side equals the right chunk over right side will always work.
What do you mean by right chunk over right side?
This side is split into two parts. Chunk 1, chunk 2. Left chunk goes with left side.
Oh, okay.
Right chunk goes with right side. And even though it's up, it'd be up chunk. That doesn't sound right.
Up chunk.
Up chunk.
Upside.
Sounds like up chuck. Needs to, regurgitate. Call for dinosaurs.
Okay.
Yell at your shoes. Toss cookies. Launch your lunch. Chunder spew. You with me?
Yeah.
Okay, so up chunk over left side equals down chunk. I should have turned that triangle probably. Well, you could turn your triangle on there. You could turn. I can't turn the board,
Okay.
but you could turn. Just now you got a left chunk, you got a right chunk.
Okay.
You can probably turn the quiz tomorrow too, even though this isn't on the quiz.
What? We could turn the projector.
We could, but I mean, I could turn this board also.
Well, if you turn the board, that's
It
not
won't
gonna
do
move.
it.
You have to
I
move
don't
the
think it would
projector.
work. You'd have to move the
I
projector.
hate smart kids. One of my other classes would have been, yeah, that would work. Guess you're right, I could turn the board, but it wouldn't.
Yeah,
It
it's
would
gonna
do
stay the
anything.
same.
Well, it would, it'd make a mess, but.
Oh yeah.
I mean, it would change,
kill
but it would
yourself.
change the projection.
Correct.
Yeah.
Correct.
Unless you.
Yeah, if I drew it on the board, then
Trace
turn the
it.
board. I could trace it.
We also have to move
Oh,
it.
yeah.
Or we could just imagine.
Like
We
this.
can believe.
We could turn his head. Yeah.
That works. Now you got left chunk and
My cheek.
Right chunk and-
Yeah, what do you got?
better.
You can't.
Magic's things.
You what?
He can't breathe from laughing.
Solve for x. On that note. Solve for x. Yeah, bomb me, boy. My fault, sorry. Sarah, what do you got?
X equals 10.
Tell me how you set that up.
I did 15 over x equals 9 over 6. And then I just
Left side over left chunk equals right side over right chunk. Perfect. Cross multiply. 9x is equal to. Ooh,
Whoa.
got kind of fancy there. X equals 10. Easy?
Easy.
Yes. Let's make it a little bit more interesting. A little bit more, not drastically interesting. Okay, try that one.
Oh, okay.
It's not quantum mechanics, it's just a different problem. May have stumped some people.
And
Katie, how long is TS?
18 minus x.
Beautiful. What'd you get for an answer, by the way?
I got 5.4.
How do we feel about that?
Yep, good.
Okay, good. Tell us how you set it up.
So I put 18 minus x over 14, and then I set that equal to x over 6.
Beautiful. Cross multiply. 60 is 108.
Yes.
Minus 6a is 14 years or 20 years. Ooh, fancy 8. You said 5.4?
Yes.
Beautiful. I would remind you in this problem, I did ask directly for x, but also be aware of the fact that I could very well ask you for TS. Could ask you for a lot of things, but I mean, that was pretty straightforward, but again, finding TS there would have just been a matter of taking this as a tracking for me. Okay, still not difficult, right? Make sure that when you apply the angle bisector theorem that you do have that angle bisector. Either the tick marks need to be included or it needs to state that TR is an angle bisector. Okay. And then we have this combination here of these sides intersecting. It also wouldn't be unusual in a, having a brain fart, proportion, thank you. In a proportion to have maybe a quadratic pop up, that would be fun, right?
That would be
No.
Yeah, that'd be fun, come on. Solve the quadratic, how many answers will you get? 2, and then what?
You see if they
You
work.
plug and check.
Plug and check, as opposed to plug and chug.
Yeah.
Plug and check, right. And what are we looking for?
We're looking to see if there are any negative sides, because
Good.
I just don't.
Distances can't be negative in this class. Awesome. We're all done?
Thank you.
So this is not